Hello, in this video, I'll be explaining my solution to the Leetcode problem, trapping rainwater. It's question number 42 and rated hard. I'll include a link in the description if you guys want to try to solve this problem before looking at this video. In this video, I will introduce what the problem is, the intuition behind the solution, the actual implementation, and then a quick runtime analysis. So to get started, in this problem, you're given an array with different numbers in it, each one representing a height. So here there's a height 0, here there's a height of 1, and then 0, and then 2, and this is like a 2-high wall. And after it rains, you're supposed to figure out how much water it can trap. So in this example, when the rain comes down here, some of it will be trapped in this little hole, some of it will be trapped in this hole, and some of it will be trapped in this hole. So if you add up all the squares, 1, 2, 3, 4, 5, 6, that's the output. So yeah, that's the introduction to the problem. And now I'll explain the theory behind the solution. And just a disclaimer, I don't know if this is the official solution. This is just a solution that I thought of, so it might not be the most efficient. Alright, so hopefully I can just draw on this. So let me try to figure this out. Alright, so first we have to figure out under what conditions can you trap water. So I'll go with the most basic condition. So I'll first define what I think a bowl is. So a bowl is anything that has a wall here and then a wall on this side that's equally as tall, or a wall on this side that's taller. And whenever we run into this bowl, this type of bowl structure where a wall on this side is taller than this side, then when the water comes in, it'll get trapped in this bowl. So that's pretty intuitive, right? And well, this seems pretty easy to implement because you can just loop through the array, and whenever you find a number, let's say this is 1, this is our current tallest wall. Whenever we find another wall that's 1 or greater, let's say 2, we know that we have a little bowl here that can trap water. And then we'll update our tallest wall to 2, and then whenever we find a wall taller than 2, let's say this is like 4, we'll know we can trap water in here. Well, now you might be thinking that this will actually miss a couple bowls, because while this would work for a bowl shaped like this, it wouldn't work for one shaped like this, because this wall isn't taller than this wall, but it would still trap water in it. But this problem is just easily solved because initially when we scan the array from left to right and look for these bowls, we'll detect all the bowls that look like this bowl, and then we'll miss the bowls that look like this bowl because this wall won't be our previously tallest wall. And then it's just a simple matter of scanning the array from the other direction with the same method, and that will catch all of these bowls. And this method also conveniently solves the problem of having a bowl that kind of looks like this, where you kind of have like a little bowl here and a little bowl here. Instead of having to find both of these bowls, we could just since we come here and then come here, we'll just pretend this is one big bowl and find out how much water it can trap. So the main caveat to be careful about is when we detect two walls of equal size. We don't want to count these twice. So what I do is, in my first iteration in the left, I will count a bowl that has two walls of equal size. But when I iterate from the right, I only count it if this wall is taller. So that way we avoid double counting these bowls. So that actually is all that the problem is. And yeah, so now to basically implement this, what we can do is basically to simulate this, we'll have a for loop going through the array, and basically keep a counter, keeping track of our current tallest wall that we've seen. And whenever we see a tallest wall, what we can do is we can start from this index with the previous tall wall, and then go over to this index, and basically what the idea is let's say this wall has a height of 3, so then this will be the height of the bowl. So now if we have like a block of 1, we can just do 3 minus 1, because the height of the bowl minus this area will give us how much water lands in this spot, and then do the same with these other spots and sum it up, and that's how much water this bowl can trap. And then it's just a matter of summing it all up and returning the answer. So I'll show you guys what the code actually looks like here. Right, so here we are given the int array heights, and here is my sum that I'm just going to be keeping track of how much water we can trap. And this is the previous index of the previously tallest wall. So here, I don't know if this is necessary, but it just makes it very convenient to code. I move my previous index until I detect a wall that's greater than 0, because if we notice here, even though we detect a wall that's taller here, we can't trap anything on this side because it'll just run off. So I move my previous index until I detect a wall greater than 0. In this case, that's 1 in this black box here. And then now we just do the algorithm that I described earlier. So starting from this wall, we move forward in the array, and whenever we detect another wall that's just as tall or taller than the previous index, so if this new wall is taller than the previous tallest wall, then I will go from the previous index plus 1, so this spot, and then I will sum up all the water that can be stored at each index. So this can be easily seen with this bowl right here. So when I detect this wall and this wall, I'll start from here. I will add 1 because this is 2, 2 minus 1, 1, and then this is 0, so 2 minus 0 is 2, and then this is another 1, so 2 minus 1 is 1, so then I will be adding 1, 2, and 1 to my water with this code right here, and then I will set my previous tallest wall to the next wall I see. And then you just do the same logic, but starting from the other side here, which is pretty self-explanatory. And as you can see here, the only difference is that instead of doing if the next wall we see is greater than or equal to, we only count it if it's greater than. Because, for example, when because for example, if we see a bowl here that's like equal size, this will already be counted. So yeah, that's essentially the theory behind it, and this will still work even for weird bowls like this, because if you think about it, when we go from left to right, we won't find this bowl right here, but when we go from right to left, we still will, because when we find this wall of 2 height and we find this wall of 3 height, we'll be able to do with a height of 2 minus the height of 1 block, and then 2 minus the height of 2 is 0 blocks, so we'll still find this. And this happens to be a very good solution. And if we click submit here, well, I already done this before, but yeah, it is quite fast. Its memory usage is not the best. That's because I think you can probably do with a little bit less like extra variables. I don't know exactly what they're called, but yeah. And so to wrap it up, the runtime of this solution would be O of n, because each loop from the left to the right, the most we'll be able to have to loop is 2 times n, and same from the right, so that's 4n, so that simplifies to O of n. So it's a quite fast solution. There might be ways to optimize it, but this is the one I thought of. That's the end of the video, and thanks for watching.